Hello, I'm Joel Fareed. I'm the program manager of the Art and Technology Lab here at Lab. I'd like to thank you all for coming today. We are very pleased to have Jonathon Keats here to talk about his concept of reciprocal biomimicry. Jonathon has come up with a number of interesting projects. I'm not going to go too much into it because he'll be discussing them today. But some of the highlights that he's done in the past include extraterrestrial abstract art, a restaurant for plants, a porn theater for houseplants. Also, he is known for, probably one of his best known projects is copywriting his mind. And I'll let you go a little bit more into that. But what was really interesting about this project and what really grabbed me, and I just wanted to just quickly share, was that by the nature of the intellectual property rights that he would get from copywriting his mind would give him 75 years to live basically after he died. This is if you take into the account of the idea of I think, therefore I am, so you have others thinking for you after you've essentially ceased to exist. And so Jonathon's going to speak for about 45 minutes. He'll be here afterwards as well, so feel free to hang out, talk to him about some of his projects and some of his other works. He has some great prototypes here that he's going to share. And without further ado, I'd like to welcome Jonathon.
Over the past decade or so, I've become increasingly interested in biomimesis or biomimicry. For those of you who may not know, biomimicry is a process by which engineers will take ideas from other organisms, from plants and animals for instance, and apply them to human needs as technologies that might be useful in our own world. So one of the classic examples, just to kind of bring you up to pace on this, is from the 1940s. Apparently, and this may be apocryphal, but all good stories are, there was an engineer in Switzerland who came back from a hunting trip and found all sorts of burrs stuck into the fur of his dog. And being an engineer, he looked at these burrs and thought not about how annoying it was or what sort of vet bill he would have, but rather that this might actually be something that would be useful. Namely, that he could take the burrs and use them as a means of attaching one fabric to another, or in other words, could make Velcro. And so Velcro comes about as a result of this kind of keen observation of something that has been solved for totally different reasons. Obviously, none of these burrs were going around wearing sneakers. They, however, were solving a problem that, with a little bit of imagination, could be used by humans for totally different purposes. An idea that's a little bit more out there, but I think kind of suggests the direction that biomimicry has gone since the 1940s and 50s, is a bird that is called the kingfisher, that, as the name suggests, is very good at fishing. The thing about the kingfisher that you might notice that is especially prominent is the beak. And the beak is very well designed for fishing. Specifically, the kingfisher is able to dive down into the water without perturbing it so that the fish don't get scared away. So when engineers in Japan were working on the bullet train, they had a problem. Namely, the train would go in and out of tunnels and make an enormous amount of noise. So as they were looking at that and how to solve it, they realized that basically what is happening is the train is going from one density gradient to another, which is the problem that was faced by the kingfisher as well. And that if they were to take the kingfisher beak as a foundation, they could come up with a way of designing a train that would not have that problem. And indeed, as you can see from this picture here, the trains that you will find in Japan use the Kingfisher as their basis in design. Now, there are many other examples that range from butterfly wings. The iridescence is highly useful for television displays. And on the other hand, if you look at the toe pads of frogs, you find that they're starting to get used as far as tire treads. And all of these are fascinating to me, yet at the same time, a little maybe disturbing, problematic in the sense that we continually are plundering these ideas that are developed by other organisms, only then to expand our own place in the world at their expense. In other words, that biomimicry is kind of a little bit of an unfair exploitation of ideas coming from the natural world that only serves to undermine nature in the long run. And so that got me thinking about how perhaps we could expand what we talk about when we talk about biomimicry. That perhaps there could be a sort of a reciprocal biomimicry that would turn the equation on its head. That is to say that human technologies could potentially be used by other organisms for their own benefit, not for ours in any way whatsoever, just as the Kingfisher, in no way that I'm aware of, is benefiting from the bullet trains and these frogs are not benefiting from tire treads. So this is, I guess, in a sense, something that has interested me for a while without realizing it. That is to say that a number of projects that I've undertaken in the past have, in various ways, involved reciprocation from one species to another, me happening to be human, to other species. For instance, plants, which, well, in 2011, I opened a restaurant for plants. And the restaurant was a very particular sort of a place that, because plants don't eat in the way that we do, was kind of made for their particular needs, their way of living. Namely, what I did was that I looked at sunlight. And where plants are, on our table, used not only as nutrition, but for incredible meals that get into all sorts of gourmet territory, plants, when you look at them, are really just eating. They're just taking in the sunlight. It's kind of boring. So I started to think about how I could perhaps make sunlight gourmet. And I realized that there was a technology that was out there. There was some research out there that could potentially lead in that direction. Namely, that in Siberia, a lot of research had been done on how plants could be grown more efficiently. And as a result of this research, there was a lot known about the effect of different parts of the light spectrum on plants. And if I then took that idea and started looking at classic cookbooks, Julia Child, for instance, I found that there were certain ways in which basic nutrition was turned into cuisine for us based on various metabolic systems in place, based on various ways in which we experienced that food on the table. And so what I did was I opened a restaurant that was specifically for plants. And what I did was I built some large filters that would filter the sunlight, the spectrum over the course of the day, so that what would happen would be that the plants would get a little bit of blue followed by green followed by red, for instance. And this was not arbitrary. This was as rigorously scientific as could possibly be, given that I'm not a plant and given that the research was, for the most part, done in the Soviet era. But nevertheless, it seemed like it was still relevant today, and that I could play with a light spectrum so that, for instance, if I wanted to add a little bit of spice, spiciness is kind of a funny thing for us. It's what we get when we eat a plant that basically is trying not to get eaten. And there's a way in which it kind of is a little bit almost frightening, the experience of eating something spicy. And for plants, what is kind of scary is well, other plants, because other plants get in their way. So far red light reflects off the leaves of plants, and if you use far red light, I think you can actually have a sort of a spice that you can add to your photosynthetic cuisine. And so that is what I did as one of the many examples of the cuisine that I offered in my photosynthetic restaurant. I've also worked with plants in other ways. For instance, making movies for them. I didn't know what they would like, so I kind of started out where most filmmakers do, which is that I started making pornography for them. So basically what I did was I went out with a camera and I filmed honeybees pollinating flowers, which is titillating stuff if you happen to be a plant. And I then went and I opened up a corn theater for plants that took this material and basically, as you can see there, if you were a plant, you would notice that there's a bee hovering in a very titillating way. And if you then take that and you project it onto the foliage of plants, they are very well equipped to watch movies because of the photosynthesis that they perform just as a matter of course. And so there's a way in which, like, vicariously, they could, even though they were indoors, they could experience what happens outside, the birds and the bees and all that sort of stuff. And so I went from there to other sorts of entertainment for plants. I attempted to go legit a few years later, thinking about plants and how they don't ever get to go anywhere. They're rooted in the ground, so therefore maybe they would enjoy travel documentaries. Now, of course, if you're a plant, your sense of travel is maybe a little different than it is for us, or your sense of place even is a little bit different, because you're not going to care about the Eiffel Tower, for example. You're going to care about the sky. So what I did was I filmed skies in Europe, which I then projected onto the foliage of houseplants in New York. And they were able to, in this case, experience a little bit of Italy from afar. And I hope they enjoyed it. But at the same time, it didn't really necessarily do them a whole lot of good. And plants need a lot right now, more and more so with climate change, where in fact travel is very much an issue. But vicarious travel isn't going to get them anywhere. Namely that as a result of climate change, plants often find themselves in the wrong place at the wrong time. As a result of climate change, you have plants that are in the wrong temperate zone, for instance. And so if you look at plants very closely, closer than I've done, if you read a researcher who's looked at plants, what you find is that plants actually try to migrate. They don't do it very well, though, because, as we talked about earlier, they have roots that are stuck in the ground. So they can only get maybe at most 10 vertical feet per year, I think is what has been measured in the Amazon for some really fast plants. And they're not literally uprooting and moving, obviously. They are, and by the way, that is not the Amazon for those of you who are familiar with geography. But these plants are moving by dropping seeds, and the seeds that sprout tend to move up a little bit in altitude in order to be able to cool off. And many plants, including some of these here, have a much tougher time doing so. And as a result, I started thinking about this concept of reciprocal biomimicry and whether there were human technologies that might help plants to get where they need to go. And there's one technology that seemed to me that was especially appropriate, which was the self-driving car. Now, plants can't drive. There are no driving plants here, but there's also no video. Well, take my word for it. Plants can't drive. And so if you think about how they could possibly get around, it seems to me that a self-driving car would be the way to go. So if you think about every single plant having its own self-driving car, you suddenly have a much more dynamic way in which plants can adjust to climate change, to the changing ecosystem. But of course, a self-driving car in its own right won't do much good. The plants will simply get around on the freeways then where are they going to go? So you need some way in which plants are able to communicate with each other in terms of where they are and how good it is, how good it feels. But once again, we have a great technology to be able to do that, which is, of course, the fitness app. So the idea is to think about plants in terms of what might work as a Fitbit for a tree that would constantly monitor the well-being of the plant from the plant's own perspective. And every plant having its own fitness app, then being able to communicate with every other plant in a way that would be kind of worked into a system where the self-driving cars would know where they needed to go, and you would end up ultimately with, I think, an incredibly successful life, an incredibly successful future for plants. Now, of course, some of this is speculative. As we all know, self-driving cars are speculative for people at this point. There are a couple of them that Google drives around and makes a big deal about, but aside from that, they aren't out there. So in order for you not to walk away thinking that everything I'm saying is totally ridiculous, I would argue that, in fact, we could start right now on what is working very well, namely on the fitness app, which is something that could immediately be very useful for plants if you think about forest management, for instance. So I think that there's a way in which reciprocal biomimicry can kind of start at a ground level of things that would be highly useful, but can then move beyond that into realms that are slightly more, as I say, speculative. And while we're talking about things that are speculative, I'll give you one more example. I'll talk about whales. Whales are in big trouble for many reasons, but one reason is to do with the effect of sonar. Sonar are being used more and more, especially in terms of mapping out the ocean floor for finding oil. And the effect of sonar tends to be highly disorienting at the very least, and often will lead to mass beaching, because whales are kind of operating in the same frequency spectrum in terms of their communication with each other as the frequency spectrum of sonar. So I don't think that it will be very easy to get ExxonMobil to change their ways. And same is true of the military, which is, of course, using sonar mostly for purposes of navigation as well as for communication. So how do we think about this as a problem for reciprocal biomimicry? Well, naturally, what we think about are invisibility cloaks. Invisibility cloaks are used right now primarily in laboratories and, of course, in Harry Potter novels. But in laboratories, they actually are working extraordinarily well for very specific parts of the spectrum. And not only for the light spectrum, but also for the spectrum of sound, including the spectrum that is covered by sonar. And basically the way in which it works, what you're seeing here are light waves that are basically being curved in a way that they curve around the object and come around the other side as if the object weren't there. And this is achieved using what are known as metamaterials. And the effect is very good if you, for instance, are in the military business and you want to get a tank from one place to another, or a submarine. But also, a side effect of this is that from inside the system, it is as if whatever signal was propagating around you had no effect, because the signal is basically kind of wrapping around you. So if you think about this, for a whale, if you were to provide whales with inaudibility cloaks that would allow them to avoid the detrimental effect of sonar quite effectively, and would not require Exxon to do much of anything, which they're not going to do anyway. So I've also been working on slightly more, well, you'll be the judge as to whether they're practical, but I've been working in a slightly more concerted way on a couple other technologies, a couple other examples, for which I've built some prototypes that I am going to show you today. And these other types of technologies are based on, again, on other problems, other issues that we tend to find out in the natural world. One of which is once again to do with climate change. And it is one of the least expected, perhaps, of the effect that has come about, which is thunderstorms have been increasing, as many of you may have read. But the effect of thunderstorms, when they get especially intense, is that they create very strong updrafts that will bring levels of moisture into the stratosphere that are well beyond what ordinarily would be there. The stratosphere, in fact, is usually extraordinarily dry. They're already up in the stratosphere are, thanks to us from a while back and our heavy use of hairspray in the 80s, there are a lot of chlorofluorocarbons, CFCs. And for the most part, these CFCs have kind of gotten to a point where they are not so much of a problem anymore. You, of course, have read about the hole in the ozone layer over the pole that has gradually self-healed. But when you have moisture, it starts a whole new set of chemical processes where it becomes highly reactive again. And the result of that is that you end up with a lot less ozone. And as a result, not only a lot more sunburn, but also cosmic rays are able to get through much more effectively. Now, NASA and ESA and various other space organizations have thought a lot about cosmic rays, not in terms of the ozone layer, but in terms of astronauts going to exciting places like Mars. And the problem that they are faced with is a problem where effectively they are not protected by any atmosphere. So when you think about an atmosphere that is being depleted by the effect on the ozone layer that I just described, and therefore greater number of cosmic rays, you can start to look at these technologies that have been developed by NASA in terms of spacecraft and spacesuits that might potentially be highly useful. So shielding, of course, is what we're talking about here. And in the case of shielding, it all is extraordinarily counterintuitive. You would think that if you were to go around in a lead suit, that would probably be the best way not to get up to the moon because it would be heavy, but to be out in space because if you're going to the dentist, for instance, and getting an X-ray, that's what they put on. But for high energy cosmic rays, it doesn't really work that way because of the fact that essentially what happens is you have a lot of neutrons, and whenever a neutron gets hit by one of these cosmic rays, you end up with a shower of particles that do an enormous amount of damage. So as a result, you actually want to go the opposite direction. You want to go lighter rather than heavier. Hydrogen is, in fact, the optimal way to go. And so I've been thinking a lot about that in terms of ways in which we might be able to develop spacesuits for other organisms that would help to get them through a period where cosmic radiation is set to increase. Now, if you think about organisms, there are some that come to mind perhaps when you think about spacesuits. That would be mollusks, snails, for instance, which basically have their own natural spacesuit, protective mechanism that allows them to get by on Earth. That worked very well in the Holocene, but in what is sometimes called the Anthropocene, this time period of intense change due to human impact, no longer is it the case that this shell is necessarily going to do everything we need to do. And the cosmic radiation is a perfect example of it, that the calcium chloride is not necessarily going to be especially effective. And so I started out by experimenting with various ways in which you might be able to use plastics. Polyethylene has a lot of hydrogen and is in fact used experimentally by NASA and by ESA in some spacecraft as a means of being able to block out that radiation. But when you start to look at it and the mess that I've made on this experimental shell, and the fact that I haven't really gotten very much protection here, you start to think maybe that's not the way to go. So spacecraft don't have an advantage that we do, which is the fact that we're here, which means that we have a lot of water. And water has a lot of hydrogen in it. So as a result, research has been moving in the direction also of thinking about water and water as shielding. And that's the direction that I've gone here in terms of building spacesuits that are appropriate for mollusks in our own current environment. Basically, that snail has worked very hard, or its forefathers have done so, evolutionarily speaking, to get to the point where it has a lung, only one, but the lung allows it to live on land rather than in the ocean, which is where they initially evolved. But a lung, of course, is kind of a problem if you want to go underwater where you're going to get good protection. So one thing that NASA knows a lot about, and that anyone who makes spacesuits knows a lot about, are valves. And so what I've done is I've thought about how we could perhaps redesign the mollusk in a way that would allow it to not to live underwater all the time, because of course there are dietary restrictions, but that during periods of what is known as ovomavism, that is to say periods of hibernation, but both for heat and for cold. There are long periods where snails will essentially shut down. And not only shut down, but also seal themselves off. So would there be a way in which they could do so in a place that would be a little bit safer for them, namely underwater? So what I've done here is I've built a prototype of how that might work and what that might look like. So here we have a mollusk that has had a few valves added for purposes of being able to get by underwater during those periods of ovomavism. And as you'll see, if we just start pumping, we're going to hopefully not burst this thing, but we're going to start getting some air going through. And anatomically speaking, for those of you who happen to be specialists on mollusks, you'll know that the lung is approximately up toward the top of the shell here. So you would be able, therefore, to allow for the mollusk to live happily and safely underwater while at the same time experiencing all of the benefits of air. And even more so, given that air pollution is not necessarily what you want as a mollusk, that this could be easily filtered. And of course, we could work very easily with these so that I, for instance, had, when I had a little more space, connected one mollusk to another. So you get whole colonies of them subsisting very happily during periods of ovomavism underwater. But at the same time, water is not necessarily such a good thing for other reasons. Namely, if you look at pollutants in the ocean, and also if you look very specifically at ocean acidification, and if you look at the relatives of land snails, at sea snails, and also at any other mollusk, effectively what is happening is that the increasing acidification that happens as a result of carbon dioxide absorbed in the water results in all sorts of problems in terms of shell formation and shell solidity. So what if we were to do what astronauts do best, or what NASA does best, which effectively is to override evolution in any way that NASA chooses to do, allowing us to be able to subsist on other planets where it would take a very long time for us to evolve by natural means to be able to live on the moon or Mars, that we are able through the spacesuit to do so relatively rapidly. And so the idea is, in the case of my land snail here, that I allow this land snail to, through a sort of evolutionary prosthesis, which is what a spacesuit really is, I've allowed the snail to be able to happily subsist underwater. So the same thing can apply for a water snail that also experiences long periods of hibernation when we start to go up onto land. So once again, during the same time period, what you can do is you can start pumping water through the gill system of the snail. So look at what we're doing here. We have a valve that is going down into the water, and we have blocking this side of the room here. We have a valve going down into the water. Maybe I'll try picking it up. That is drawing water out, and of course we're going to filter this, and we're also going to be able to use buffers that will decrease the acidification, and effectively we have a very happy mollusk. It's leaking right now because, once again, we're talking about holomovism, but nevertheless, it is able during this period to go through long spells where there are none of the effects of ocean acidification or of the pollution involved, and I'm about to underline everything here because this now starts to take a plunge. So let me try to upright, I think I go upright here, which it is not going to do. Okay, so the island design needs to be better than I've achieved here, admittedly, but these are advances for engineers, and my background is, as you probably guessed, more in the arts. And so that is, I think, kind of a good case history to give you an idea of how we might go about reciprocal biomimicry. And I've also developed yet another plan. I'm sure that you've been waiting for one more. But once again, I have been looking at issues to do with us and the problems we are making for other organisms. And pollution comes up. But pollution takes many, many different forms. And one of the forms that pollution takes that is actually rather surprising, that only recently has been figured out at any level whatsoever, and by recently I mean May 2014, there was a paper in Nature that was detailing for birds the effect, there are birds here, the effect of the electromagnetic spectrum, namely electromagnetic pollution in cities that prevents birds from being able to navigate properly. The reason for this is that birds have evolved an incredibly clever mechanism that as soon as human engineers manage to figure out exactly how it works, and they have not yet, will result in some incredible new apparatus that will cause even more problems for other organisms by way of the usual kind of biomimicry. But we're not doing that here. We're doing reverse or reciprocal biomimicry. So what I'm looking at is, are there ways in which, given this problem that is now being faced in the city with birds that effectively are getting lost because their compasses are being completely thrown off by AM radio signals, for instance, and also by the electromagnetism that is involved in power generation. So what might we do to be able to address this? Well, when you think about aviation, human aviation, what you think about are air traffic control towers. So what I've been developing are air traffic control towers for birds that will allow them very handily to be able to get around in the city and not to get into trouble in the process. And so to be able to kind of develop this idea, I took some compasses, and a lot of them, and built a board that would very locally be able to show some sort of the state of electromagnetism, and then I could very crudely take a magnet and disrupt things in a way that would be done by an AM radio station, for instance. And so the idea is basically to build these towers that use powerful electromagnets. The tower that I built is a prototype, and the electromagnet component is not at present working in this model for the purpose of being able to easily demonstrate it here. But it's using a combination of a permanent and an electromagnet, which would be highly advantageous in terms of being able to sub-navigate in terms of the subtlety of the magnetic signal. So basically what we're going to do here is to build some towers, and I've got a picture here that will make it maybe easier for you to see how this all works. And what the towers can do is they can override the local interference of that magnetism in a way that will, as the towers turn, according to measurements that are made of the local magnetism, will allow for birds to be able to find their way true north or wherever else they may happen to want to go. Of course, this solution also suggests many other opportunities. when we start thinking about having enough of these towers in place, we can also think about it in terms of cases in which, for instance, there's a fire or high smog level or something of the sort, and there are parts of the city where you really just would rather, from the standpoint of birds, that they not be. So you can use these towers effectively to change the map as far as they're concerned, so that parts of the city, magnetically speaking, are warped so that they almost don't exist. And that will allow for an on-the-fly system by which birds will be able to experience a city in a way that might perhaps be a little bit more felicitous for them. And this is, I think, a relatively easy project to start working on experimentally. And large-scale experiments are absolutely necessary because, as I mentioned earlier, this research was literally several months ago that it was discovered the effect of these radio signals. And the mechanism is still poorly understood, if at all, simply because no one can figure out how it is that signals as subtle as those could possibly be read by the bird in flight. It seems far too subtle, but nevertheless, this is the observation that's been made. And so I think what we need to do is we need to think about building some of these towers. We might think about doing it here at LACMA. So building, say, 4 or 5 control towers on campus here, and then setting up a system with an observation deck. The observation deck might be, for instance, the Japanese pavilion seems to have a good view on these. And so it would be a combination both of observation, human observation by citizen scientists or anyone who happens to come through LACMA who wants to make observations, but also more importantly by video, by constant video feed, observing birds in the wild as they encounter these towers, and basically looking, statistically speaking, as we make adjustments to the towers in terms of power level, in terms of steering and various other ways in which we might adjust them, whether we can find some way in which these can become practical as towers out in the world. And that video, of course, we would need to use data mining techniques that would involve all sorts of graphic treatment that could visually, since this is a museum after all, and there are things like pictures here, visually it actually would be quite interesting, I think, even for people who are not necessarily involved in avian research, in addition to the fact that we would then be able to move forward and to build these towers, initially probably around AM radio stations and so forth, and then ultimately really start thinking about how we can build out into cities and make this kind of a much larger sort of undertaking globally. So when you think about this, though, you might think also about the trees that I was talking about earlier, and about the problems that trees have in terms of climate change and not being in the right place at the right time. And as I'm sure you have read, birds have a similar problem, albeit for different reasons, to do with migration. When birds migrate, they tend to migrate, they tend to migrate where they've always migrated, and where they always migrated is not necessarily where they ought to be going. So that, for instance, there often are some very carefully planned, in some sense of the word, convergences where, for instance, when horseshoe crabs lay their eggs, perfectly corresponding to when birds that eat those eggs will land there as a way station on their migration. So birds are able to adjust, but it takes years. Approximately 35 years is the average, it seems, to have any sort of discernible adjustment in terms of migration pattern, which is far too slow, even though they're flying, but behaviorally speaking, they're just going to the same old place over and over again. So thinking about those magnets, is there a way in which we might be able to do something for those birds? And I think the answer is yes. I think that it's GPS. I think that if we give birds global positioning, that there would be enormous potential as far as their being able to get around. And this wouldn't be any ordinary GPS system, which they wouldn't be able to read. What we would be doing is we would be manipulating, and that sounds kind of malevolent, we would be working with their sense of magnetism using drones that would fly to the flock and that would dynamically be able to adjust the path that the birds were taking. And if you look at flocking behavior, you're really talking about birds following one another. So if you can just basically get the lead bird or birds connected electromagnetically, then you can end up with a way in which the entire flock, and then you start thinking about adding in all National Weather Services, and you basically have a way in which a drone, and I brought one here to attempt to demonstrate how this all would work, but you basically have a drone where it should be taking off. I'll try it again here. Okay, you'll have a much better drone than I've got here. I'm not entirely sure what's going on here with the very elaborate radio control. Anyone have batteries? Oh, here we go. Maybe this is the problem. Oops. So, for birds. Essentially, what we have here is we have a drone that has a very strong, this is a permanent magnet, because already, as you can see, I am utterly What I'm going to try to do here for you this afternoon is to fly this drone over my field of magnets so that you can observe Does anyone have a pilot license here? Or, good, would you like to give a try? So, yes, once we figure this out a little bit more, and as Joel mentioned, I'm going to be here until 4, so there will be ample opportunity for anybody who wants to try this out. But once we get a little better at this, then the idea, of course, would be to start doing it out in the field. And as you can see, if the field happened to be LACMA, for instance, we could have a very good drone testing field where, once again, we would be able to take those cameras and make use of big data in order to be able to make some generalized observations about ways in which we can optimize magnetism and genuinely get birds and also butterflies, which navigate by the compass, where they need to go, when they need to go there. And of course, all of this that I've been talking about really does have a lot to do with humans and their impact on the environment. There happens to be also a coincidence where a number of these things kind of come together, and for once we're not responsible. And that is that we're going through a period right now of what is known as polar wander. Effectively, what is happening is north and south poles are flipping. And as a result, we're going through a period where magnetism is decreasing substantially, and that results in a natural condition where, once again, and only increasing the urgency, we find not only that GPS might be highly useful and advantageous for birds, but also that the protection that is afforded by electromagnetism of our environment makes it so that, once again, those cosmic rays become much more problematic than they otherwise would be. So, in effect, we have the same system that's causing problems in two totally different ways that would, as far as I'm concerned, really be a basic fundamental sort of support that we should start giving. If anyone here is from the National Science Foundation, let me know, that we can start giving toward various case studies in reciprocal biomimicry. And we're now more than half a century from Velcro, and we haven't even started with reciprocal biomimicry. And so I would say that now is really the time to get started. And you are perhaps more competent than me at getting going with that. And so I would like to invite all of you to start thinking in those terms and to stay here and talk with me afterward about ways in which you can do all the work for me. So I'd be happy to take and evade any questions. Yes?
There's a documentary I saw, and it was talking about plants and how a plant could actually feel the vibration of a predator insect on its leaves, and actually starts to exude through its leaves a chemical that insect doesn't like. So I was wondering if there's a way to let's say, have plants exude something else through their leaves that maybe we would like. And
well, it's true, and actually it's an effect that is amplified because when they exude these chemicals, it tends to then, because other plants are often able to sense those chemicals, causes a chain reaction. And in fact, you find some plants that don't have that nice little mechanism in place, that they are able to kind of listen in on that communication, and that they are able also to exude various insecticides. And yes, I think that when we're speaking in terms of biomimicry, certainly there are many ways that we can go in terms of looking at the ways in which plants are dynamically able to sense and to respond to their environment in ways that are beneficial to them. That would really be, I think, fairly squarely in the field of biomimicry. So what I guess I would challenge you to do would be to think about how we could reverse that equation. That is to say that clearly pests, well, pest is relative. I'm a pest in some cases. But insects that are preying on plants often are not insects that those plants in evolutionary terms grew up with. Because of global shipping, for instance, you end up with, and also because climate change makes it more advantageous for certain insects to be in places where they have not been habitually, means that you have a system, global system, that is changing much more quickly than the system that is evolved into those plants. So maybe the question would be, are there ways in which to give plants a broader spectrum of chemicals that might allow them to not kill off all those pests, because then those pests suddenly become endangered species, and we get very excited about them, very angry at those plants, and suddenly the plants are the pests. We don't want to, we want to control our pestilence here, but are there ways in which perhaps an entire array of chemicals might be available to plants? Maybe it's just a matter of what chemicals a plant has on hand to be able to mix. I don't know whether that's the case, or maybe we need to think about it in terms of the system that is used in terms of being able to detect those insects. Maybe it's just not sensitive enough for some of the insects that are out there right now. And then I've got an obvious answer for you, which is car alarms. Think about burglar alarms on cars. It's all about vibration. Are there ways in which plants might be able to tap into car alarm systems as a way of being able to detect when insects are about to attack and cause them all sorts of problems in terms of their leaf structure, which is kind of similar to when someone breaks in and takes your radio.
Radio.
Yes.
I can't remember the name of the book. What was the name of the book, Bob? That it was about how plants can manipulate humans, and I think it was about desire, and it was that plants were able to manipulate humans. Yeah, I didn't read the whole thing. I read parts about it. There was one part about how potatoes got to migrate because of something.
Corn.
Oh, okay.
No, go on about that if you have some specifics.
Well, it wasn't my point, but I think what you're bringing up is that corn has manipulated humans to, so that it's it's invaded our lives in unprecedented ways. So I don't know if you call it mimicry.
I think that you could say the same thing about cows, though they might not like it. And corn, for that matter, doesn't necessarily like it, but there certainly are ways in which any of the relationships that we have with whatever we eat tends to, at some level, lend support to their ongoing existence as a species, even if not at the level of an individual organism. And you could certainly call that a sort of manipulation.
In regards to the first example you showed, the restaurant for plants, did you actually find out perhaps reactions in plants after maybe some days or months of being exposed?
I think that if I were thinking like McDonald's and actually how can I make some money from this, for instance, then definitely those metrics would have come immediately to mind. But I kind of thought of myself more in the sense of, celebrity chef for plants in this case. So I think it was more about trying to learn as much as I could about the physiology of plants and to learn cooking as well as I could as well for humans. And then to offer this cuisine as a highly experimental restaurant that would be a starting point for a lot more in the way of whole restaurant chains, for instance, where that kind of work might come into play. And I actually, in the case of, because I know that you're going to ask me about the pornography for plants as well, and maybe not, but in terms of whether I was looking at metrics there, once again, I had more of this auteur sort of self-image in terms of what I was doing. In porn they have them, I think, but in any case, I was thinking more in terms of what I could make as kind of a starting point. And then, honestly, I think part of what got me started in this was realizing that I don't know how to make movies. I never made a movie in my life. There are people who are much better at it, like, I don't know, Steven Spielberg or somebody, but they are essentially all tapping into human audiences, and I would never have a chance if I wanted to start making movies. So I realized that I needed to kind of reach out to other organisms, and there are a lot more trees than there are of us, so I thought I could just kind of start making movies for them, and then would end up with an enormous captive audience, which, well, there were 90 of them, which is enormous by my standards. So really it was, in every case, a starting point. And maybe I should back up a step and say that my background is in philosophy, and all the projects that I undertake, including what I've been talking to you about today, are undertaken from that point of view with a great deal of annoyance with philosophy and philosophers and where that has gone in terms of it's becoming an increasingly kind of sequestered realm in which philosophers are talking amongst themselves and the rest of us are just kind of out here not really partaking in philosophy. And I was interested and remain interested in ways in which philosophy might happen out in the world. And so each of these projects is in the sense a thought experiment, but not a thought experiment as would happen in philosophy where it's something that is posited on the page in order to make a point, to make an argument. I'm not making an argument for anything here. I'm simply saying that we can take the idea of a thought experiment literally and make it an experiment and see what happens when we follow through on a proposition that is, well, some would say manifestly absurd, and what sort of meaning might emerge from that. And my job in that case really is to be the best pornographer for plants I possibly can be, or to be as good as I possibly can be at making spacesuits for mollusks or whatever else it might happen to be. But that then the conversation that ensues around it ideally is one that both goes into the technologies that I developed, and I sincerely do think that plants can enjoy photosynthetic cuisine. I don't see why not. But also that I am human, as I mentioned earlier, and the rest of us in the room are, I don't see any plants. And therefore, I'm very interested in that sort of human conversation that can take place. I'm very interested in, dynamically speaking, when we encounter a situation that is not necessarily, that is very familiar in a sense, but also is deeply unfamiliar, such as when suddenly the plants are the ones watching the movies, and we're watching them watching movies, perhaps bringing us into a space where we can start to look at our vicarious experiences, which we often will simply take for granted to be experiences we've actually had. That moment at which it becomes foreign to us is a moment at which we can start to investigate ourselves more deeply. But as I say, my real work here is trying to get that drone to fly straight. And the work that happens when I put that out in the world, if I don't butcher anybody with it, is the work of trying to think through, in the case of reciprocal biomimicry, trying to think through, I think, what our relationship is with other organisms at every level, the level of their technologies and ours, and how we negotiate this intellectual property that is kind of a global inheritance that we have, perhaps by virtue of the fact that we have been very good kind of corporate raider types, have kind of upset that balance in a way. Are there ways in which there might be a more balanced relationship, a more balanced technological ecosystem that we could pursue? And while I do believe that my air traffic control towers for trees, or rather my air traffic control towers for birds, would be useful for birds, or could be if we get the technology to work correctly. And there are a lot of ifs there. At the same time, I believe that the broader ideas that come up are as interesting to me, and that I'm certainly by no means afraid to fail at this, and I've become very good at failure, so I think I'll do a good job at it.